Hello, math students. Today we're going to be going over the next part in linear equations, and that's solving literal equations. If you did the last few lessons and solving advanced linear equations and all that, if that wasn't too hard, then this should be not too hard also. But I would say this does get quite a bit harder. So just follow along. And if you write down everything I write and do everything I do, I promise it'll make a lot more sense. And we'll just kind of work through it problem through problem. So let's go ahead and get started. And we're going to go ahead and do this one right here. It says basically solve for n. So what do we want to do here? I hope you remember how to do this, but the first thing we would do is distribute this -2. So this -2 multiplies with both these terms in the parentheses, giving us -2 plus 14n here on the right. On the left, nothing changes. We still have a 5n plus 34. Now, notice there's n's on both sides of the equation, both sides of the equal sign. So when I see that my variable is on both sides, I don't like that. So I'm going to go ahead and get rid of this 14n here on the right. And if I subtract 14n here on the left to keep it equal. Okay. 5n minus 14n is -9n. We also have a plus 34 here on the left equals and -2 on the right after these cancel. For our next step, we're going to go ahead and subtract 34, both sides of the equation. Again, I hope you're writing this all down. This will give you -9n equals -36. These are multiplied, if you remember. -9 is right up against the n. That means they're multiplied together. So we're going to go ahead and divide to cancel out the 9. Divide by -9, both sides. Giving us that n is 4. Notice it's +4 because a negative divided by a negative is positive. Okay. This is on page 5 of the tutorial, by the way. We're going to keep on moving through the tutorial. You can skip all this stuff. I'll explain everything along the way. You'll have to skip through this and just keep on skipping until you get to page 10. It should automatically stop you. It won't let you go any further until you've answered these questions. So let's go ahead and go through this short activity. It's just a couple problems. But let's go ahead and rewrite this equation for x and express its value in terms of a. So just like we've done before, we want to solve for x. So we want to get x by itself. Now, what's key here is that notice there's multiple variables involved. There's x, but then there's also a, okay? Don't worry too much about a, except that just know that a is a number. So just like with this -4, for example, you can add it to both sides, you can subtract it to both sides, you can multiply by it on both sides or divide by it on both sides. So a is just like that. You can add a to both sides, you can subtract a to both sides, all that. So just treat a just like any other number, except we won't be able to actually compute it with the other numbers, okay? Now, it'll make more sense as we do more problems, and we're going to do a lot of problems together. So here in this case, what would I do first to solve for x? Well, hopefully you agree that we can add 4 to both sides to cancel it, okay? Adding 4 to both sides using the addition property of equality. We still have 3 over ax equals, and this becomes 24. For our next step, you can go ahead and multiply by a to cancel this a here. Then you'll have to multiply by a on the right side as well. So I multiply a here to cancel, and then I have to multiply a on the other side. This gives us 24a. Remember, if a number is just multiplied by a variable, we can just shove them together and write it as 24a. Hopefully you see that our next step or our last step to get x by itself is to cancel this 3. Notice the 3 is multiplied by x, so to cancel it, we divide by that number, by the coefficient, giving us that x is 8a. Notice the 24 divides by 3, that gives us 8. So 8a is our answer. So x equals, and then we can just write 8a. Now, part B says, use the rewritten equation from part A, so the equation we just made, to find the value of x when a equals -2. So here we're going to use the same equation, but we're going to replace a with -2 in this case. So this will say x equals 8 times a becomes 8 times -2. We're replacing or substituting the a with whatever they tell us, in this case, -2. This gives us that x is -16. Negative times positive is a negative, so -16. Okay. Now, let's go ahead and move along, and we can continue ahead like we've done before and skipping all the way till it stops us. So it'll stop you here on page 14. I'm going to put unanswered on these. And we'll go ahead and answer these questions. So here is a formula that you may have seen before. This is the formula to change from degrees Celsius to degrees Fahrenheit. So as you may already know, that in the United States, we use Fahrenheit, but in most other countries and areas around the world, they use Celsius. So what's the formula for changing Celsius to Fahrenheit? Well, that's this formula here. Now, notice what they're asking here. It says rewrite the formula to convert Fahrenheit to Celsius. Okay, so and it says use fractions instead of decimal numbers. Okay, that's fine. So we want to change this function here, and we basically want to solve for C. Solve for C. So I want to get C by itself. Now, I hope you can see I can subtract 32 to both sides of this equation. F minus 32, we can just write it like that. F minus 32 equals, then on the other side, we have 9/5 C. Notice we're closer to getting C by itself. Again, our goal is to get C by itself. Now, notice this says 9 divided by 5, essentially. So we can go ahead and multiply by 5 to cancel it. We would multiply this side by 5 as well. Notice I'm putting parentheses around this entire left side. That's because we need to multiply 5 by the entire thing here, okay? That gives us 5, F minus 32. In this case, you can distribute the 5, but I think it's actually better if we don't in this case. And then on the right side, we still have 9C. Once again, our goal is to get C by itself. So hopefully you can see that the next step will be to divide by this coefficient, 9. We divide the left side as well by 9. So there's a couple ways you can write this. You could write it as C equals, and we can call it 5/9 times F minus 32. Or you could write it like how it is here, where the whole thing is over 9. I think they're gonna want it more like this though. So, all right. Now I know this is tricky. I know this is not the easiest thing, but it'll just get easier and easier as you continue along, as long as you're following along and writing down everything I do. I guarantee it'll make your life make a lot more sense. You want to use capital C here, because they use capital C in the capital C for Celsius. So again, that was 5/9. So when you're using this equation editor over here on the left, there's this fraction. So we want to use 5/9. Parentheses. minus 32. Okay. Now it says use the correct answer or type the correct answer in each box. Okay. Round to the nearest 10th. That's the first decimal place. Hopefully you have your calculator available. Okay. Now we want to use the conversion formulas for Celsius and Fahrenheit to find the missing values in the table. So you can see here, they give you the degrees Celsius, 10 degrees, and you need to find how many degrees Fahrenheit that is. So to change Celsius to Fahrenheit, we're going to use this first equation. Okay, so I'm going to go ahead and grab that. This is for helping us change from Celsius to Fahrenheit. So my first number they give me is 10 degrees Celsius. We need to change that to Fahrenheit. So that's going to be F equals, and I'm replacing the C with 10. So this is 9/5 times 10 plus 32. Hopefully you remember how to multiply a fraction times a whole number. Remember, you could do the whole number times the numerator, the top, divided by the denominator. So 10 times 9 is 90. 90 divided by 5 is 18, I think. Yeah, 18. And we have 18 plus 32, which gives us 50. So here we're going to put 50. Let's go ahead and do this other degrees Celsius to Fahrenheit. So here it's -5 degrees Celsius. We need to figure out what's the temperature in Fahrenheit. So once again, we're going to use the same formula, except I'm going to replace the C with -5. So it's going to be, here, this one I'll do in blue. So it's going to be F equals 9/5 times C, but again, I'm replacing the C with -5. These are parentheses here. That's not a C, that's parentheses. Plus 32. So you're just rewriting the same formula, except replacing C with whatever they tell you. In this case, -5. So to multiply 9/5 times -5, we multiply times the top, then divide by the bottom. That'll give us -9. Right? -5 times 9 is -45. -45 divided by 5 is -9. Then we have a plus 32 over here. So -9 plus 32 is 23. So in this case, -5 degrees Celsius is the same as 23 degrees Fahrenheit. Now, as you can see, they're also asking us to change Fahrenheit back to Celsius. So for this first one, it's saying 87 degrees Fahrenheit, change it to Celsius. For that, to change Fahrenheit to Celsius, we're going to use this formula that we discovered earlier. Here, we're going to replace the F, the Fahrenheit degrees, with 87. Just replace it with whatever they say. In this case, 87. So that's going to be C equals 5/9 times 87 minus 32. Okay, now how do we figure out what this is over here? Well, we do the parentheses first, right? With our order of operations, we do parentheses first. So 87 minus 32. So that's going to give us 5/9 times, what's 87 minus 32? Well, that's 55. C equals 5/9 times 55. So again, you take this 55, multiply by 5, then divide by 9. 55 times 5 divided by 9 gives us 30 point, if you have your calculator, you'll see, and it has 5 repeating forever. Okay, now it says to round your answer to the nearest 10th. So that's the first decimal place right here. So when we're rounding, you would put 30 point. Now, should I put 5 or should I put 6? Should this round up or stay the same? Well, it should round up because you look at the number behind it. The number behind it, if it's 5 or more, rounds this up. Okay, so that's going to be 30.6 is our degrees Celsius, rounded to the nearest tenth. Okay, last one, we're going to use that same equation, but this time replace F with 10 degrees Fahrenheit. So that's going to be, let me change my color. C equals 5/9. And in this case, the Fahrenheit is 10 degrees Fahrenheit minus 32. Okay. So that's going to give us C equals 5/9. In this parentheses, 10 minus 32 is negative 22. Again, you multiply by the numerator, divide by the denominator. Okay. Negative 22 times 5 divided by 9 gives us negative 12 point, and you'll see 2's repeating. 2, 2, 2, dot, dot, dot. Okay, so to the nearest tenth, that's this decimal place. In this case, it stays the same. It does not round up because the one behind it is also a 2. And if this is less than 5, it does not round that up. So negative 12.2 is what we would put. Perfect. You can see all the work here once again, but let's go ahead and move on. Why do you think it might be useful to rearrange formulas before solving for one of the variables? Relate your answer to the Celsius and Fahrenheit formula and examples. All right, so why do you think it might be useful? Well, when we were using this example and we were solving for the Celsius, it would have been more of a pain if we used this one, okay? Because you'd have to replace the F with a number and then work it out with that, like that. But here, C is already solved. You know, you see C is already by itself. So when we replace F with the given values, then we just need to use the order of operations and compute it. So that's relatively simple. So basically, you can write that it makes certain calculations simpler, especially when you have to do multiple calculations using the same formula, okay? Because then instead of having to solve, you just have to just compute. Okay, so briefly explain that there. I've already explained it just right now. So if you need to, you could re-listen to that. Okay, once you're done with that, let's go ahead and move on to this one. All right, in science, when a force moves an object, it's called work. Scientists use the term to describe the amount of force applied to an object that moves that object. Work is measured in a unit called joules, using the formula W equals FD, F times D. In this formula, W is the work, F is the amount of force in newtons, and D is the distance over which the force is applied in meters. So again, W is work, F is force, and D is distance. If applying 6 newtons of force to an object results in 42 joules of work, what distance in meters would that object travel? So this is pretty relatively simple one. We're going to go and grab this work formula here. And here it says we're going to have 6 newtons of force. So that gives us our F. So our F in this case is 6 newtons. N for newtons. And then it says 42 joules of work. So for our work, our W, that gives us 40, it tells us it's 42 joules. So how much distance is that? So what we need to do is we're going to replace W with 42 and F with 6. So that gives us 42 equals, again, replacing the W with 42 and replacing the F with 6. So 6D. We don't know what D is yet, but we could easily solve it. To get D by itself, we're going to go ahead and divide by 6 on both sides of the equation. That'll give us D solved, which is 7 meters. Okay. Let's go ahead and go to page 17. Here we have this formula. A equals 1/2 B times H to solve for the base, B. So we want to solve for B. We want to get B by itself. Okay. We don't need this. We don't need this. We want to get B by itself. So the first thing I would say is, well, we have A equals 1/2 BH. So it's 1/2 times B times H. The first thing I would do is multiply by the denominator, in this case 2. Multiplying by 2 will cancel out this 1/2. But that means I need to multiply the left side also by 2. Remember, whatever you do on one side of the equation, you have to do the exact same thing on the other side of the equation. This gives us 2 equals BH. Now remember, we're trying to get B by itself. So our next step will be to get rid of H. Get rid of H. Remember, these are multiplied, right? So in order to get rid of it, you're going to divide by that same factor. Divide by H on both sides of the equation, giving us B all by itself. It's 2A divided by H. Okay, so over here, let's go and use this fraction over here on the equation editor. It was 2A divided by H. And there you go. Let's move ahead until they stop us. Okay, they stop us on page 23. So we're going to go ahead and work this out. All right. Here we're doing conversions. So this is hopefully not too bad, but it says convert the value from meters per second to kilometers per hour. 1 kilometer equals 1,000 meters. 1 hour is equal to 3,600 seconds. Type the correct answer in the box. So right now we have 105 meters per second. So I'm going to go ahead and grab this right here. We have 105 meters per second. And we want to change it to kilometers per hour. Okay. Well, one thing that I kind of think about here is we have 105. I'm going to go ahead and put this on top like this, meters per second. Okay, so this is 1 second. So 105 meters in 1 second. Now my goal is to get it in kilometers per hour. And we're going to have to use a couple of conversions here. So first, we need to change from meters to kilometers. They're both types of distance, but we want to change from one type of distance, meters, into another type of distance, kilometers. Now, it says here that 1 kilometer is equal to 1,000 meters. So what we're going to do is multiply by a ratio with meters and kilometers. So 1 kilometer, 1 km, is equal to 1,000 meters. Okay. Now, why do I write the ratio like this? Why do I put the km on top and the m meters on bottom? Well, if you think about fractions, you can see, hopefully, that this m would cancel with this m because this one's on a top and this one's on a bottom. Our meters cancel. These units of measurement cancel. That leaves us with kilometers in the numerator, which is what we want, right? Because our answer needs to have kilometers in the numerator. Notice our next ratio we're going to write has to do with changing from seconds to hours. So our next ratio is going to involve seconds and hours. Should I put the seconds on top or on bottom here? Well, in this case, I put my seconds on top. 3,600 seconds is the same as 1 hour. Notice I have a seconds term on top and a seconds term on the bottom. Those seconds cancel. And this should make sense because what I'll be left with is hours in the denominator, which is good. That's what I want. I want an H in the denominator. Oh, they don't put HR, they just put H. Okay. I wanted H in the denominator, which is what we have. Okay. Hopefully you're writing this down. Now, to figure out the answer, what we're going to do is you go ahead and multiply all your numerators together. 105 times 1 times 3,600. That gives us 378,000. Okay. Over, now we're going to multiply all our denominators. So 1 times 1,000 times 1, well, that's just 1,000. So we have 378,000 kilometers over 1,000 hours. We can reduce this fraction by 1,000. So just go ahead and divide top divided by bottom, top divided by bottom to get our answer. And you should get 378, and this will be kilometers per hour. Good. So again, multiply all the numerators, multiply all the denominators, and numerator divided by denominator. Anita purchased apples priced at $1.79 per pound at the grocery store. Her receipt shows that she spent $5.37 on apples. Type the correct answer in the box. Anita purchased blank pounds of apples. Well, this is a pretty easy one. What we want to do here is notice that $1.79 per pound. So it's $1.79 times the number of pounds. We're just going to put X for the number of pounds. And that'll give you your cost, which in our case, our cost was $5.37. Now our goal is to get X by itself. So we're going to go ahead and divide by $1.79 on both sides of the equation. Remember, we do it on both sides to keep it equal, giving us that X is 3 pounds. She purchased 3 pounds of apples. Okay, let's move along. It's going to stop you here on page 27. So let's go ahead and work this out. All right, 4 questions. A device in your school lab releases gas at a rate of 0.25 liters per second, which means 0.25 of a liter of gas is released every second. The density of the gas is 4.3 grams per liter, which means that there are 4.3 grams of the gas in 1 liter. Set up the calculation to find the number of seconds it'll take for the device to release 154 grams of the gas. Okay. So find the number of seconds it'll take for the device. Okay. So we want to be left with seconds in our answer. Okay. Well, you can see the only thing that has seconds, we have two ratios here. Let me go ahead and grab everything here, grab everything we need. Okay. So you notice we have two ratios here. We have this 0.25 liters per second, and we have this 4.3 grams per liter. So these two ratios are going to be put in these two areas here. Okay. Now they're already kind of giving you a hint. Do you see how this one has seconds here? Well, there's only one ratio that has seconds in it. That's this one here. So that means that one needs to go here. 1 second is 0.25 liters. Okay, so 1 second, 0.25 liters. Notice I had to flip this ratio, but that's okay. You're allowed to flip these ratios however you want. Now the other fraction here is 4.3 grams per liter. Should I put it like that? 4.3 grams per 1 liter? Or should I put 1 liter, 4.3 grams? Well, I want my grams to cancel so that I don't have grams anymore. I want to cancel. I want to be left with just seconds. So that means I want to put my 4.3 grams down here. That way it'll cancel. This one is basically a numerator, and I want it to cancel with a denominator. I put the 1 liter up here. Now, it also makes sense that the liters would cancel too. So that's good too. That way it leaves me with just seconds, right? Because my grams cancel like this, my liters cancel like this, and I'll be left with seconds. So go ahead and click and drag these things here. 1 liter, 4.3 grams, 1 second, 0.25 liters. It will take blank seconds for the device to release 124 grams of the gas. So here, now we just need to find our answer. Remember, you multiply the numerator times numerator times numerator. So in this case, that's 154 times 1 times 1. So that's 154. And then in the denominator, you multiply 4.3 times 0.25, giving us 1.075. Just divide these. Giving us 143 point, let's see. Round to the nearest whole number, so 143. It was 143.2. So we round to the nearest whole number, which is where the 3 is. Would this 3 round up or stay the same? Well, it stays the same because this 0.2 is less than 5, so that does not round the 3 up. You can see the calculation, same as what we did, right? All right, this one's a very similar one, except we're dealing with here, meters per second and joules of energy here. So it says a car travels at a speed of 41 meters per second using 756 joules of energy every second. So we can already see where this is going, hopefully. But basically, this first ratio is 41 meters for 1 second. That's this first ratio. The other ratio was 756 joules of energy every second. So 1 second. Again. Okay. Suppose that we know the car uses 52,700 joules of energy. So that's where this 52,700 joules comes from. Set up a calculation to find the number of meters the car travels with this amount of energy. So using our two ratios here, notice this has blank meters. Well, that means I'm going to use this ratio right here because I need that meters, right? 41 meters, 1 second. Okay, now this other fraction, I'm going to be using this 756 joules per second. So since since these joules right here are in the considered on the top, the numerator, we need the other joules in the denominator to cancel with this J canceling with that J. All right, per 1 second. So here's our setup. And I hope you can see that this J would cancel with this J. This S cancels with this S, leaving us with just meters, which is what we want. We want our answer in meters because it says how much distance does it travel, right? Yeah, find the number of meters the car can travel, right? So again, to calculate this, you multiply top times top times top over bottom times bottom times bottom. So you can think of this as over 1. So 52,700 times 1 times 41. 52,700 times 41. 216,0700. Hopefully you got something similar using your calculator. On the bottom, we have 756. Then you go ahead and divide that. Which gives us 285 or 2,858. Let's see. Yeah. Okay, cool. Let's see. That's going to be the next question, isn't it? Perform the calculation, round your answer to the nearest whole number. The first decimal place is 0.0. So would that round the 8 up or keep the 8 the same? Well, keep the 8 the same, right? 2858. Cool. All right, so that was it for the tutorial. So once you've done that, go ahead and try the practice. So once you've done the tutorial, you would click on the practice, and we're going to go over the practice questions right now. So here I've got all the practice questions. Again, follow along, write down everything I write, and you should have a reasonable understanding of what's happening. This first one's kind of tough. Rewrite the formula to find the base B sub 2. Now, notice you have two different B's in this equation, right? You have B sub 1 and B sub 2. Okay, whenever you see those subscripts, those don't actually do anything mathematically. What they are actually only doing is giving us a distinction between two different bases in this case, right? So when we have multiple of the same type of thing, sometimes we'll give it a subscript so that we can tell the difference between one and the other, okay? But since they're both bases, they both get the variable B, but to show that they are different bases and they can have different values, that's why they have those different subscripts, okay? It's not something you're going to see often in Algebra 1, but it is something that comes up often in mathematics as a whole. So just be aware that when you see those subscripts, they don't really do anything mathematically. It's just to distinguish two items of a similar type. Okay, so our goal here is to solve for B sub 2. So I want to get B sub 2 by itself. Well, the first thing I would do is I would multiply both sides of this equation by 2. So I'm going to multiply this side by 2 to cancel out this denominator. That means I need to multiply this side by 2 as well. So that gives us 2a equals, and I'm going to go and put parentheses here, b sub 1 plus b sub 2 times h. Notice the h is multiplied by this parentheses here. So in order to cancel it, we're going to go ahead and divide both sides by h. Dividing both sides by h here cancels this factor, giving us 2a over h. Continue our work down here. 2a over h equals, and here I don't need the parentheses any longer, b sub 1 plus b sub 2. Now remember, our goal is to get b sub 2 by itself. So I need to get rid of this b sub 1. So how do I do that? Well, I'm going to go ahead and subtract b sub 1 both sides of the equation. Because it's added here, we subtract to cancel it. So I'm going to subtract b sub 1. Leaving us with b sub 2 by itself over here on the right side. That's good. That's what we want. On the left side, we have 2a over h minus b sub 1. Okay, kind of a tricky one. They get easier, okay? Number 2, our goal here is we want to, says find the cost of each friend's meal in terms of A. So we want to get X by itself, where X is the cost of each friend's meal. So we want to get X by itself. So let's go ahead and do that. So the first thing I would do is subtract 6 both sides of the equation using the subtraction property of equality, giving us AX equals 41 minus 6 is 35. Now we want to get X by itself. Remember, AX means that A and X are multiplied. So in order to cancel it, we're going to go ahead and use division. Divide by A on both sides of the equation. That way we can get X by itself. So 35 over A. So we're going to put here. Find the cost of each friend's meal when the number of friends is 5. So again, our equation was X equals 35 over A. A is the number of friends involved here. So since there are 5 friends, we're going to replace the A with 5 in this case, giving us X is 35 divided by 5. $7. All right. Next one. P equals 2 times L. That's not a 1. It's not 21. It's 2 times L in this case, plus 2 times W. This is for the perimeter of a rectangle. L is the length of the rectangle. W is the width of the rectangle. Solve the formula for W. So our goal is to get W by itself. All right. Well, the first step here, I would go ahead and subtract 2L both sides of the equation. Notice I write my L's with a little loop. That way I don't confuse it with a 1. Okay. So on the left side, we have P minus 2L equals, now this 2L and minus 2L, those cancel. That's good. That leaves us with just 2W here on the right. To get W by itself, we divide both sides by 2. And that's your answer. So make sure P minus 2L over 2. Make sure to use this fraction tool right here when you type this one in. Okay, solve the following equation for X. So we want to get X by itself and express its value in terms of C. So we want to get X by itself. Now you may notice I can distribute this 3 here and to here. And that is that's acceptable. You're allowed to do that. I've shown you how to do that before, multiplying the 3 by each of these terms. And you could definitely solve it that way. But in this case, I actually am going to divide by 3 on both sides to start. That cancels out this, leaving us with cx minus 7 equals 9 divided by 3 is 3. Okay, you see how I'm allowed to do that? Because these are multiplied. I can cancel that with division. Okay. The reason you could do that in this case is because the 3 is multiplied by every term on this side. Like in another case, you might not be able to. Like if you had 2x, just as an example, if you had 2x plus 1 equals 7, you couldn't like, oh, divide by 2 here. Like that does not work, okay? But since this is in parentheses, that means the 3 is multiplied by this whole thing. You can divide that factor out, okay? It's just a little bit of algebra knowledge. Okay, now in order to help me get x by itself, I hope you see that I could use the addition property of equality, adding 7 to both sides of the equation, giving us cx equals 3 plus 7, which is 10. Lastly, to solve for x, we're going to divide by c. Divide by c. X is 10 over c. Make sure to type that here. Question 5. I want to solve for x once again. I want to get x by itself. You can see there's an x over r minus s equals t. Well, my first step, I'm going to go ahead and add s to both sides of the equation, giving us x over r is t plus s. Notice I curl my t's so I don't confuse them with plus signs. Then you would multiply by r on both sides of the equation. Multiply, I need the parentheses here to show I'm multiplying this whole side by r, giving us x equals, I could throw the r in front, t plus s. The ideal gas equation says that the product of the pressure, P, and the volume of the gas, V, is equal to the number of moles of the gas, N, times the gas constant, R, times the temperature of the gas, T. Which of the following equations is represented to the ideal gas equation? So, here they're solve for V, they got that. Solve for T, they got that. Solve for N, they got that. Solve for R, they got that. Okay. So let's go ahead and work this out and just solve for each of these as we go. So the first one is V. They solved for V. So if I took this equation and solved for V, how would I do that? Well, I hope you could see I would divide by P on both sides of the equation. So V, correctly solving for V would give us N, R, T, these are all multiplied together, divided by P. So is that the correct, is that what they did correct here? No, that's not right. Don't click that. Okay, so it's not solving for V, they did not do that correctly. Well, maybe they solved for T. So let's go ahead and solve for T. To solve for T, to get T by itself, I need to get rid of N and R. So to do that, I divide by NR, canceling both. I'll just do them both in one step. Divide by NR. So PV over NR to get T by itself. Oh yeah, PV over NR, that's correct. The other ones must be wrong somehow. solve for n. So we want to get n by itself. Once again, you see how this has this 180 factor in front of this parentheses? I can go ahead and divide both sides by 180 to help simplify my equation, giving me s over 180 is n minus 2. To get n by itself, we're going to go ahead and use the addition property of equality to cancel this 2. So this gives us s over 180 plus 2 is n. All right, this one, keep in mind for this one, it's mark all that apply. So in other words, multiple of these may be correct. Okay, and in fact, 2 of these are going to be correct. So we need to figure out which 2. The slope-intercept form of a line is y equals mx plus b. We're going to go over that formula in particular quite a bit in later units. Y equals mx plus b. It's the slope-intercept form of a line, where m is the slope and b is the y-intercept. If Sean knows that the slope of the line is 4 and the line passing through the point is 1 comma negative 8, which equation should he use to find the y-intercept and what is the y-intercept of the line? So this is a complicated one, but essentially they are solving for b because they're solving for the y-intercept, which b is the y-intercept. So we're solving for b. So let's go ahead and write it out. Y equals mx plus b. And I want to solve for b. So hopefully you can see that I would go ahead and subtract mx both sides. Subtract mx. Subtract the mx term on both sides, giving us b by itself. On the other side, we have y minus mx. B equals y minus mx. Now we have to use the other information they give us. It says the slope of the line is 4, so the m is 4, and then it passes through the point 1 comma negative 8. This tells us the x and the y. X comma y. So the x is 1, the y is negative 8, and the m is 4. Okay, so I'm going to replace the m, x, and y in this equation to find b. So let's go ahead and do that. So I'm going to replace y with negative 8 minus this minus m times x. So that's 4 times 1. 4 times 1. And that'll give us our b. This becomes negative 8 minus 4 times 1 is 4. Negative 8 minus 4 is negative 12. Number 9, almost done with the practice. 1 meter equals 39.37 inches. About how many feet are in 3.6 kilometers? Okay, so 1 meter is 39.37 inches. Okay. So we have this ratio here. And it says how many feet are in 3.6 kilometers. So a couple of other things we need to know here is that there are 1,000 meters is 1 kilometer. We also need to know how many inches are in a foot. So 12 inches is 1 foot. Okay. So we have 3.6 kilometers, 3.6 kilometers. And we want to change that into feet. So here we're going to multiply by some ratios. So I want the kilometers to cancel. So I'm going to use this ratio right here to cancel out my kilometers. I'm going to put the 1,000 meters is 1 kilometer. This will allow my kilometers to cancel. Now I also want the meters to cancel. I also want the meters to cancel because I want to be left in feet. That's what I want. I want feet. So I'm going to multiply by, to get the meters to cancel, I'm going to use this one right here. Should I put the 1 meter on top or on bottom? Well, I'm going to put the 1 meter on bottom so that it cancels. Top cancels with bottom. 39.37 inches. Notice that means my meters cancel. That's good. Now I need inches to cancel because I want to be left in feet. So I want it to be feet. So I'm going to multiply by 12 inches is 1 foot. Should I put the 12 inches on top or the 12 inches on bottom? Well, the 12 inches goes on bottom to cancel with this inches. Top cancels with bottom. So that's 1 foot. All right, this is kind of a complicated one. Inches cancels. Now to figure out our answer, we multiply top times top times top times top. So 3.6 times 1,000 times 39.37 gives us I'm not going to use red. Gives us 141,732 feet. And multiplying the denominator, 1 times 1 times 12 is 12. So you're going to have to divide this out, divided by 12. Gives us 11,811 using my calculator. Okay, question 10. The pressure applied on any object can be calculated by using the following equation. P, that's the pressure, equals force divided by area. In the pressure equation, P represents the pressure on an object measured in pascals. F represents the force applied on the object in newtons. And A represents the area in square meters of the object over which the pressure is applied. What is the pressure applied inside a container having an inner area of 16 square meters? So that's the area, so that's going to be our A, 16. And a force of 1,306 newtons. So here's our force, F. And we need to find the P, the pressure. Okay, so P equals the force divided by the area, 1306 divided by 16. Rounded to the nearest whole unit. So I got 81.6, round to the nearest whole. So this 1 rounds up to a 2 because the 6 rounds it up. If this is 5 or more, that rounds it up. So 82 pascals. Okay, let's move on to the mastery test. Once again, write down everything I write, do everything I do, it'll make sense, or at least more sense. I'm going to give you at least a hint on each problem. I will do some problems fully, and some problems I'll just give you a hint or a first step or something. Now, keep in mind, your mastery test only has 5 questions. I have 20 questions here. So you will be given 5 questions out of these 20. I'm not sure, I don't know which questions you're going to be given, but you'll be given 5 of these 20. Okay, I will be going over at least some of every question. So you will get some help on every single question of yours. And but if you follow along and you just pay attention to what I'm doing, it'll make a lot of sense for you. Okay, this first one, the formula for the centripetal acceleration A is given by the formula where V is the velocity of the object and R is the object's distance from the center of the circular path. A is acceleration. Okay. A equals velocity squared divided by R, the object's distance, radius. Solve for R. Okay, so my goal is to get R by itself. So it's kind of a tricky one. So I'm going to go ahead and go over it with you. So A equals V squared over R. Now, my goal is to get R by itself, but notice R is in the denominator. Whenever I have a fraction that I want to cancel, I'm going to use multiplication, right? Now, you always multiply by the denominator if you want to cancel a fraction. So I'm going to go ahead and multiply by R, canceling it. But that means on the left side here, I'm going to multiply by R as well. So on the left side, we have RA equals, and on the right side, we have V squared. Now, my goal is to get R by itself. So we're going to go ahead and divide by A on both sides. R equals V squared over A. So when you write this down, make sure you're using the equation tool. You're going to be using this fraction tool to start. And then when you type in V, you're going to use this tool right here because you need V to the power of 2, right? So you're going to use this one, and then you're going to put a squared right here. Then when you go into the denominator, make sure to put A. So your answer should look like this. The formula for the volume V of a cone having a radius R, a height H is shown below. So V equals 1/3 pi R squared H. Write the formula to calculate H. Okay, so the first thing I would do is see how this has a 1/3 in front. So we're going to multiply both sides by 3. That cancels out the 1/3. So we have 3V equals, then on the other side we have pi R squared H. Now see how these are all kind of just mushed together? That means they're all multiplied. So in order to cancel out the stuff we want to get H by itself. So we divide by pi R squared, divide by pi R squared. That'll give you H by itself. Okay, for this one, let's see. Find the value of X in terms of P. So we want to solve for X. Notice the 4 is a factor of this side over here. So we can go ahead and divide by 4 on both sides of the equation, giving us P times X plus 1 equals 64 divided by 4. I believe that's 16. Yep, 16. Go ahead and subtract 1 on both sides to cancel this 1, giving us Px equals 15. To solve for X, we're going to divide both sides by P. So X equals 15 over P. So go ahead and put that here. I think you just need to write 15, and you'll be using this slash P, right? Because it says use the slash for fractions. Okay. And then replace P with -5 to figure out what this result is. So it says find the value of X when P is -5. So replace P with -5 and divide that. Okay. This one's very similar to the one above. So The first step here, I would say divide by -2, divide by -2. This will give you bx minus 5 equals -8. Okay, go ahead and see if you can do the rest from there. If you need an example, look at the one we just did above. Okay. Solve the equations for x and match the solutions. Okay. So for this first one here, we would subtract 7 both sides of the equation, giving us 2ax equals 13 minus 7, which is 6. Then I would divide by 2a, giving us x equals 3 over 2a. That 3 and 2, that could reduce, right? By 2, right? So that's 3 over a. Okay, so 3 over a. This one goes here. All right. I'll also do this next one with you here. My first step here would be to subtract 5 on both sides of the equation. Subtract 5, giving us -1. 4 minus 5 is -1, equals 6 over a x. Okay. Then what we could do is multiply both sides by a. Multiply by a, giving us -a over here on the left. These a's cancel on the right, equals 6x. Divide by 6 both sides to get x by itself. So -a over 6. Okay, see if you do the last one on your own. That one's the easiest one, I think. All right, here's the conversion one. This one's kind of dreaded. Okay, water drips from a faucet at a rate of 41 drops per minute. 41 drops per minute. So that's 41. We'll put D for drops in 1 minute. Assuming there are 15,000 drops in a gallon, so 15,000 drops in per gallon, so per 1 gallon. How many minutes would it take for the dripping faucet to fill 1 gallon bucket? Round your answer to the nearest whole number. It would take blank minutes to fill the bucket. So we want 1 gallon. Okay. And we want to figure out how long that's going to take. Well, they do 41 drops in 1 minute, and we need 15,000 drops. So we need 15,000 drops, and they do 41 drops in a minute. So just divide this by 41, and that'll tell you how many minutes. So divide that, and I'll give you that. Round to the nearest whole number. Keep that in mind. Here we want to solve for A. This one's a bit tricky, but we can do it. My first step, I noticed that this entire right side is divided by 2. So I'm going to go ahead and multiply by 2 to cancel that. Multiplying the left side by 2 to keep it equal. So I have 2s equals, and then we have A plus B plus C. Now my goal is to get A by itself. So I'm going to go ahead and subtract. Let me change colors here. I'm going to go ahead and subtract B both sides, as well as subtracting C on both sides. I'll just do them both in one step. Here, subtract B and subtract C on both sides, right? Given the following formula, A equals 27, T equals 3, solve for R. So I could replace A with 27 equals P, I don't know, doesn't tell us what P is. Then we have 1 plus R times T. T is 3. So I'm just going to write 3R instead. Plus 3R, like this. Okay, my first step, I think, will be to divide both sides by P. Divide both sides by P. So that'll be 27 over P equals, these P's cancel, 1 plus 3R. Subtracting 1 on both sides of the equation. Cancels this one, leaving us with 27 over P minus 1 equals 3R. Then I would divide, well, I see what they're doing. This one's going to be a little bit tricky, but I want to show you this. So you notice they have a 1 here. We could rewrite that 1 as P over P. Okay. Now, why would I want to do that? Well, that means I could rewrite this 1 into P over P, and we can actually combine these two fractions because they're minusing. I need the same denominator. So since they're subtracting, I need the same denominator. So I could rewrite this left side as 27 minus P over P. And then again, over here, we have 3R. Divide both sides by 3. Divide this by 3. Let's cancel here. That gives you R equals, now what happens here? We have a fraction divided by 3 here. Well, you'd write this as 27 minus P over, and this 3 can just multiply with that P in this denominator. So 3P. Yeah. That was a complicated one. This one, solve for X. Okay. The first thing I would do is add G to both sides to cancel that out. Okay. So that gives you negative Fx equals H plus G. See if you could solve it from there. Again, you're trying to get X by itself. All right, here's another complicated one. Here we have a lot of subscripts. We have Y subscript 2, so Y sub 2 minus Y sub 1 divided by X sub 2 minus X sub 1. Okay. And we want to see which of these is a correct way to solve for one of these variables. Okay, I see the answer. Well, what I would do is, see how this has a fraction? This denominator here is X sub 2 minus X sub 1. So I'm going to go ahead and multiply by that denominator. X sub 2 minus X sub 1. This cancels this, but that means I need to multiply this left side similarly by X sub 2 minus X sub 1. This gives us, and I'm gonna put this on the left side here, Y sub 2 minus Y sub 1 equals M times X sub 2 minus X sub 1. Now, I'm going to get Y sub 2 by itself. So we're going to add Y sub 1, add Y sub 1. That gives me Y sub 2 by itself. And this is correct right here, isn't it? M X sub 2 minus X sub 1 plus X Y sub 1. That was a complicated one. Okay. We want to solve for x once again. Okay. Now, a couple ways to approach this. You could try to find the lowest common denominator and multiply everything by that. But in this case, I think I'll just add this 1/4 to both sides of the equation. Okay. So on the side here, I'm going to write 5/2 plus 1/4. To add fractions, you need a common denominator. So in this case, my common denominator is going to be fourths. Okay. This second fraction doesn't change. It's already in fourths. But this one, you needed to multiply by 2 to get to a 4 here. So that's 10/4 plus 1/4. So now we have 2/3 cx plus 1/2 equals, when you add these together, that's 11/4. For our next step, I'm going to go ahead and multiply by this one's reciprocal. So 3/2 to cancel this fraction. Multiply by 3/2, giving us cx plus 1/2 equals 33/8. Oh, this one's not fun at all. Next, I would subtract 1/2 to get rid of this. To the side here, 33/8 minus 1/2. Remember, we need a common denominator when adding or subtracting. So we're going to go ahead and change both these fractions into 8ths. This one doesn't need to change, but this one will. To change to 8ths, I multiply by 4 in the denominator, which means I multiply by 4 also in the numerator. 33/8 minus 4/8 is 29/8. So I've got cx equals 29/8. Lastly, to get x by itself, we're going to divide by c on both sides of the equation. I discussed this briefly before, but when you have a fraction over another, divided by another thing, you can just multiply the denominator times this denominator, giving you 8c in the denominator like this. Here we go. Okay, solve for r in this one. So these are all multiplied over here, 2 times pi times r. So to cancel out this 2 and pi, you divide by 2 pi. And then you do the same over here. Here's solve for v. Well, my first step here, I think, would be to subtract c both sides of the equation. So on the left, we have s minus c, and then equals 1/2 a squared v. Next, I'm going to multiply by 2 on both sides of the equation, canceling out this half. This side gets multiplied by 2 as well. So we have 2 s minus c equals a squared v. These are multiplied, so see if you can figure out what to do from there. Solve the equation for x here. Well, my first step will be to use the addition property of equality, adding 4 to both sides of the equation. See if you can do it from there. Here we're solving for h. I think we did this exact one earlier. Okay. Well, we're going to multiply by 3 to get rid of this 1/3. Multiply by 3 on both sides of the equation. 3v equals, this 3 and 1/3 cancel, a squared h. Next, to get h by itself, you're going to divide by a squared. So Here, solve for y. So my first step will be to add z to both sides. Whenever I do a z, I always cross it because I don't want, here's my 2 and here's my z. I don't want to confuse my 2 and my z. So I always put a cross on my z. I suggest you do the same. Most math people do. Add z to the other side as well. So that gives you w plus z equals x minus y over 2. To cancel out this divide by 2, well, we're going to multiply by 2. Multiply this side by 2 as well. This gives you 2w plus z equals x minus y. Okay. To get y by itself, we're trying to get y by itself. We're going to go ahead and subtract x, canceling this. This gives you 2w plus z minus x equals negative y. Now keep in mind this is a negative y, which means I need to get rid of that negative also. You can think of this as a -1 times y. So to cancel it, you can divide by -1 on both sides of the equation. Well, that gives us y by itself. That's good. Now on the left side, that changes both these signs. So instead of a +2 here, it's going to be a -2. Instead of a negative x, it's going to be a positive x. So I'm going to put my positive x first, and then minus 2 parentheses w plus z. Okay. That was a tricky one, I would say. Okay, we did one very similar to this before. Which of the following equations is equivalent to the formula for velocity? So here we have a lot of subscripts. You just read this as velocity equals d sub 2 minus d sub 1 divided by t sub 2 minus t sub 1. Now my first step will be to multiply by that denominator, t sub 2 minus t sub 1. That cancels with this one's denominator, but that means you need to multiply it on the other side as well. T sub 2 minus t sub 1. With my t's, I always curl my t's on the bottom here. That way I don't confuse them with plus sign. Okay, I suggest you do the same. So on the left side of the equation, we have v times t sub 2 minus t sub 1 equals d sub 2 minus d sub 1. Okay. Luckily, they were nice to us. We're going to add d sub 1 to both sides. That gives us that v times t sub 2 minus t sub 1 plus d1 plus d sub 1 equals d sub 2. Okay. A pound is approximately 0.45 kilograms. A person weighs 87 kilograms. What is the person weight in pounds when reduced to the nearest whole number? So you take their weight in kilograms and you divide by this 0.45, and that'll tell you their weight in pounds. Okay, round to the nearest whole number. Solve for x here. My first step will be to subtract p on both sides of the equation. Okay, so that'll give you negative qx. I give my q's a little tail here, so I don't confuse them with a 9. R minus p. Okay, see if you could solve it from there. given the formula below, solve for x. So this is actually the point slope formula of a line. And we want to get x, specifically this x, by itself. So notice there's two x's involved, but there's only one that we're solving for this x here, okay? So the first thing I would do is divide both sides by m. That gives us y minus y sub 1 over m equals, and we could drop this parentheses now, we don't need it, x minus x sub 1. Now my goal is to get x by itself, so I'm going to add x sub 1, add x sub 1 to both sides of the equation, giving us x by itself. Y minus y sub 1 over m plus x sub 1. And there you go. Is that it? Is that the last one? Wow. Okay. Well, hope that made sense. All right. Hope you're able to get through it. I do want to say that this is probably the hardest lesson or one of the hardest lessons in the entire class. So for the entire Algebra 1 class, both semesters, I would say this is one of the hardest lessons. So if you're able to get through this, if it made sense, then you're on your way to doing very well in this class. If it was still very difficult, which I imagine for some it probably was, don't worry about it too much. Let's just do our best here and move on. If you want to say thank you, then please just subscribe or share my content, this video or my channel in general with someone who might find it helpful, your teacher or a classmate. Okay, well with that, thanks for watching and I'll see you guys next time. Take care.